Hello everyone, today I will be presenting about PBE1 of data structure. My name is Jayshree Selvakumar and I am from DDT 3A. Okay, so the first question is implement the following basic operation for a queue using a linked list in C++ code. So firstly, they asked to create a queue. As you see, queue open bracket, close bracket, and then bracket front equals to rar equals to null ptr semicolon close bracket will be a code of creating a queue. So the queue constructor initializes an empty queue by setting both front and rar pointers to a null ptr. All right. So next is check if queue is empty. So to check the queue is empty, the code will be bool is empty, open bracket, close bracket, bracket, return front equals null ptr, semicolon, close bracket. So the is empty method checks if the front pointer is null ptr. If it is, the queue is empty. So the next question is add an element to the end of the queue. So to add an element, you have to use this code as you see white enqueue int value bracket node star temp equals new node open bracket close bracket semicolon temp arrow data equals value semicolon temp equals temp arrow next equals null ptr semicolon if open bracket is empty open bracket close bracket front equals rar equals temp semicolon else rar arrow next equals temp semicolon rar equals temp semicolon and close bracket would be the code. So the enqueue method creates a new node with the given value and adds it to the end of the queue. So if the queue is empty, it sets the both front and rar to this new node. Otherwise, it links to the new node to the current rar node and also updates rar to the point of the new node. Alright, so next is we have to remove an element from the front of the queue. So to remove an element, we should use this code, which is void dequeue bracket if is empty, cout, q is empty, return. Node star temp equals front semicolon front equals front arrow next semicolon if open bracket front equals null ptr close bracket rar null ptr semicolon and then delete temp. So the dequeue method removes an element from the front of the queue and it also first checks the queue is empty or not. If it is, it prints queue is empty and exits. Otherwise, it moves front to the node. If front becomes null PTR after the removal, rar is also set to null PTR. Finally, it also deletes the removed node. Okay, so the next is they ask to print all the elements in the queue. So to print all the elements, the code must be this, but we have to add this um, um, white display if is empty. So is empty, cout q is empty, return and a node star temp equals front semicolon while temp null ptr cout temp arrow data temp next. So the display method prints all the elements in the queue by traversing from the front to rar. It checks if the queue is empty or not first. If it is, it prints queue is empty. Otherwise, it iterates through each node and prints the data until it reaches the end of the queue. So this code will display, will print all the elements in the queue. All right. So okay, next, this is actually the main function of the code. So to display the output of this code, you have to use this main function, which is, as you see in the code, int main bracket q q q and q10 and q20 and q30 and then display. So it will be displaying this outputs, and the output will be this. So 10, 20, 30, and then below that will be 20, 30. All right. So let's go to the second question. So the second question is, below are operations for a queue using a linked list, and they ask to draw the changes happening after each statement is executed. All right. So this is the illustration of the create queue. So this will be front and rear, which initialize an empty queue. Okay. So next they ask to NQQ and 2024. So we have to insert the 2024 in the front. All right. So next is NQ 2020 again. So if we need to NQ, so we have to insert. So insert 2020 continued by the point in the middle. As you see, the middle point uh, is um, is continuing with the arrow to show the inserted value, which is 2020. All right. So next they ask to DQ, which is delete. They ask to DQ 2020 uh, DQ. So the remaining value would be 2020 since we DQ'd the 2024. Okay. So the next is NQ 1969. So by continuing from 2020, which is in the front, we continue by inserting the point to the arrow showing that we have inserted 1969 in the rear position. And next would be DQ. They ask you DQ again. So if we DQ, if we delete the in front value, it will be the remaining will be 1969. Okay, so let's go to the question number 3. So question number 3 shows, consider a linear queue with capacity of 7. Perform the following operation and draw the state of the queue after each operation. So first is create linear queue. So if we need to create a linear queue, it must be a blank queue, linear queue. So there's no any value inserted, so the front and rear would remain 0. The next would be in NQ, they asked to NQ10. So if we NQ10, we have to insert from the beginning. So the 0 position will be 10, and the front's value is 0, as you see, and rear is 1. Okay, the second is NQ20. As we see, NQ20, we have to insert 20 in the linear queue, and the value of the rear would change and the front would remain the same. As you see, rear is 2 and front is 0. Okay, so NQ30, and it is still the same, which is we insert 30 and the rear would change to 3. Next, NQ40, we insert 40, the rear would change 4. The next is NQ50, same, we insert 50 and the rear would change 5, the front would remain same. Okay, now we DQ, which is we delete a value. If we delete a value, we should not delete from the back. We should delete from the front. So if we delete from the front, the 0 will be remaining an empty box, and the other values would remain in the boxes that they were in. So the front value would be 1 and rare is 5. Okay, they asked to dequeue again. If we delete another one value, it would be front will be 2 and rare would be 5. NQ60, we should insert 60 and the front is 2, remaining 2, rare would change to 6. Okay, NQ70, we insert 70, front remains same and rare would be uh, 0. Okay, so DQ, they asked to DQ. So if we DQ the value, the front would change and dry remain 0. We DQ again, the front would change to 4. So they asked to NQ80, the Q is overloaded so it can't be add on it. Okay, so we'll continue with question 4. Question 4 is consider a circular queue with a capacity of 5. Perform the following operation and draw the state of the queue of each operation. So they asked to create a circular queue. This is a circular queue with an empty values in the circular. Front rare count would remain 0 since there's no value added or deleted. NQ10. So if we NQ10, which is insert 10 in the circular, the count and rare would change to 1, front would remain 0. Okay. They asked to NQ20, insert 20, rare and count would change to. Okay, same NQ30, insert another value which is 30, front would remain 0, rare and count would change to 3. NQ40, they have inserted 40 and rare count would change to 4, front would be 0. NQ50, same, insert 50 and rare count would be 5. They asked to DQ. So if we DQ a value, we have to DQ the first value which is 10. Okay, if we DQ 10, the rare and count would be 4. DQ again, delete another value, it would change to 3, rare and count. And NQ60, the rare and count would be 4. NQ70, we insert 70, the rare and count would be 5. DQ a value, the front will be 1 since DQ the front value and rare count would be 4. And DQ again, rare count will be 3, front will be 2. NQ80, the circular is overloaded, so we cannot add on that. Thank you.